Now, chapter 2 here, as you can see, okay? Here, what we're going to do is we're going to start looking at other stuff. Like, for instance, in chapter 2, so here what we're going to start looking at, I'm just setting the timer on my watch. All right, there we go. We first start looking at the Cartesian plane, okay? The Cartesian plane, okay? That is something you probably have seen before. I mean, I'm pretty confident they teach it in high school. If you haven't seen it, that's okay. I mean, whenever you are asked to graph an equation, not just necessarily in math, but even in the sciences, like I think physics and chemistry and stuff, you are working in the Cartesian plane. Okay, I think someone's microphone on. Hold on. Let me see if I can mute everyone. I'm going to mute everyone because I think someone's mic was on, so. Okay. All right. But again, you know, whenever you're asked to graph something, okay, in the you're working in the Cartesian plane. It's a very, very useful device. You know, so we will see that today. Not only that, we're also going to see what's called the distance formula. That allows you to determine the distance between 2 points in the Cartesian plane. There is a formula for it. I do sketch the proof as well. I'm not going to ask you guys to prove it on an exam quiz or whatever. Not to say you can't handle it. I just don't think, I think for this class that sketching proofs is not the best idea. Not to mention it's in the book as well. But you'll see it's actually just based on Pythagorean's theorem. You know, it's a special theorem about right triangles. Also, we'll see what's called a midpoint formula. So we will see that as well. Okay, so that's good. Let's get started. So for the Cartesian plane, okay, well, what is it? Well, the Cartesian plane, if you have, let's say we have 2 copies of the real number line, okay? You know, we saw what that looked like before. One of them is vertical, as you can see. The other is horizontal, as you can see as well. So in other words, they're perpendicular, meaning they intersect at a 90-degree angle. Okay? We're going to call the horizontal number line the x-axis. The vertical we're going to call the y-axis. So horizontal is the x-axis. Vertical is the y-axis. Where they intersect, that's going to be called the origin. Basically, what we're going to see is, just like with the real number line, that's a way of visualizing all real numbers. The Cartesian plane is going to be for visualizing all ordered pairs of real numbers. All ordered pairs of real numbers. But we're not quite there yet. Here I just made it a little more concrete, so to say, in that I labeled the axes with numbers. This I actually drew. Well, I didn't draw it by hand, of course, but I made it using GeoGebra. Let me just write that out. GeoGebra is a very nice tool. Oh, there. Oh, I couldn't see that. Okay. Basically, with GeoGebra, it's a graphing tool. I don't know if you're on campus or not. I'm pretty confident it is already on the, what do you call it, the campus computers. I know you could download it for free. You don't have to. I think there's also a graphing calculator made by GeoGebra through Lumen Learning, which I made available. At least I hope I did. You can also use Desmos as well if you want, whatever's easier for you. You know, GeoGebra is a little bit trickier to work with than Desmos, but it is very nice. But basically here, I'm just showing you the Cartesian plane, right? They intersect, okay? As you can see, the number lines, the axis, where they intersect, that's going to be 0 for both lines. That's going to be 0 for both lines. And then, of course, you can label as we've seen before, right? Okay. So it's a visual representation of all ordered pairs of real numbers A, B. That's what the Cartesian plane is for. A here, we actually call it the x coordinate. And it's actually going to come from the x-axis. That number, A, comes from the x-axis. B, that's also a number, represents a number. It's called the y-coordinate. And as you can see down here, although I'm not there yet, it's going to come from the y-axis. That's what's going to happen. So A is called the x-coordinate because it comes from the x-axis. B is called the y-coordinate, and it comes from the y-axis. The origin, that's just labeled as 0, 0. Okay. I've seen some books also call A the x-coordinate. The first coordinate, the y-coordinate, B, I've seen called the second coordinate. Just something I wanted to point out. I hope I get this terminology right, but I think the x-coordinate is also called the abscissa, and the y-coordinate is also called the ordinate. I don't think our book uses that terminology, and I might be even saying the words wrong. It's just something I wanted to, point out, though, that terminology. Now, how do you actually plot an ordered pair of numbers in the Cartesian plane? That's what this is for. The whole idea is you locate A on the x-axis. Where is it? Oh, here it is. You could also think of it as starting at the origin, and then you're moving to the right, A units, if A is positive. Or if A is negative, you're going to go to the left instead. Once you get to A, you're going to go up or down. You go up B units if B is positive, and you're going to go down the absolute value of B units if B is negative. It's almost like you're starting at the origin. The x-coordinate tells you how far to go horizontally along the x-axis. To the right, if your A is positive. To the left, if your A is negative. Then, for B, the y-coordinate, that tells you how high to go up or down. Not on, but kind of like, how do I say this, like along almost the y-axis. You go up if B is positive and down if B is negative. Now, this might be a little tricky to see. So this slide, I zoomed in a bit with dashed lines. Hopefully that makes it easier to see. But again, the idea is not hard. You probably have done this before. If you haven't, that's okay. But the whole idea is, although this point should be over here, but you locate A on the x-axis by moving to the right or left. Then you go up or down. You go up B units if B is positive, down B units if B is negative. That's the whole idea. Okay. Now, let's just do some quick examples. So here we have our Cartesian plane with numbers labeled. So if I wanted to get to, or plot that is, 1, 2, okay? You go to the right 1 unit, because the x-coordinate is 1, and then you want to go up 2 units. Here's 1, 2, right? Because the y-coordinate is positive 2. Okay, so you can imagine plotting this point by doing what I just said. Over here, if we want to plot, let's say, imagine plotting -2, 1.5, right? We locate -2 on the x-axis. And in this case, we go to the left 2 units. Now you go up 1.5 units, like so. So in this case, again, our y-coordinate is 1.5. So we're going to go up 1.5 units. Finally, for this point, for -3, -1, we go to the left 3 units, because 3 is negative, the x-coordinate. Then we go down 1 unit, like so. As you can see, to the left 3 units, because 3 is negative, the x-coordinate. The y-coordinate's -1. We go down 1 unit, like so. Okay, so, just some quick examples. Before we get to this, let me just change the recording. Discard it, I guess.